Hello, pre-calc. So we are only going to be covering 3 sections in Chapter 8, the 3 sections that deal with identities, so that we can wrap it into what we're doing with Chapter 7. And in this particular section, the linear combination property is what we're going to be looking at, where you can take a sum or difference of cosine and sine and write it as a singular cosine argument so that we can solve equations. That's mainly our goal here. So the idea is you have a coefficient on your cosine and a coefficient on your sine, and if you put those together using Pythagorean, it gives you the coefficient on your singular cosine term. So the way this is looking, so you have x or theta here. I'll put an x since that's what we have there. And remember, b always goes with the adjacent because it's in front of the cosine. C would be the opposite. A represents the hypotenuse. And so you can see that they are joined, connected by the Pythagorean theorem, which is how you would find A. And then to find the horizontal shift, you're going to do a tan off of the opposite over the adjacent. Now, you are going to have to be careful here because D, notice, represents, really that should say inverse tan, opposite over adjacent. You want to be careful if your actual angle ends in the second or the third quadrant, because remember, your principal values are going to come for tan from the first if it's a positive ratio and the pre-first. So in either case, if you're in the second or the third, you'll have to take what the calculator gives you and add 180. And we will look at an example of how that works. All right? So that's what this cuidado is about. You want to make sure you take note of where your angle ends, where the B and the C lands you. All right, so let's look at this first one. Y equals 4 cosine x plus 3 sine x, and we want to use our linear combination. So right off the bat, hopefully you know that this A is going to be 4 squared plus 3 squared. It's a 3, 4, 5 right triangle, basically. All right, and since it is 4 and 3, so here's your adjacent, your opposite, here's your hypotenuse. That puts us in the first quadrant. And so there's not going to be any issues here. I'm going to go ahead and do my inverse tan, opposite over adjacent. You want to be in degree modes for all of these. And that's going to give me 37 degrees. So once I have my A and I have my D, I can basically put this all together. So y equals 5 cosine x minus 37 degrees. That would be your final answer. All right, let's look at this next one. So here we have y equals negative 15 cosine x plus 8 sine. So that is going to put me in the second quadrant because you're going to come back a negative 15 and you're going to go up 8. And here's my hypotenuse. So this is really the angle that we're looking for in terms of D. You can do your Pythagorean theorem. If you remember your triples, this will end up being 17. So we know A is going to be 17. If I do my inverse tan now, so that's going to be the opposite over the adjacent. What the calculator is going to give you, because that's a negative ratio, is it's going to give you negative 28 degrees because it's going to be between negative 90 and 0. Obviously, negative 28 degrees does not land you in the second quadrant. So to get there, you are going to just add 180 to that. So that D is going to actually be 180 minus 28, which is 152 degrees. So then your final answer, when you put it all together, is y equals 17 cosine theta minus 152. So you want to make sure you give that angle based on what quadrant you landed in. That's probably the number one mistake. All you have to do is just plot that adjacent and the opposite, the B and the C, so you know which quadrant you're in, and then adjust accordingly. All right, well, what if we wanted to go the other way, that it comes to you as 1 cosine, but you want to expand it? You're just going to use the property that we learned earlier, cosine A plus B, or in this case, A minus B. So let's stick with that. Where's my undo? A minus B. Remember that equals cosine A, cosine B, plus sine A, sine B. So we're going to utilize that property to expand this. So this is going to become 20, and then I'm going to put a big bracket here. So we have cosine x, cosine 60, plus sine x, sine 60. And then we evaluate. So cosine x, nothing you can do with that. Cosine of 60 is 1/2. Sine x is what it is. Sine of 60 is rad 3 over 2. All right, so now if I distribute my 20, and really it's only going to affect the numbers, basically those are going to reduce to 10 in the numerator. So this is going to bring me y equals half of 20 is 10 cosine x plus 10 rad 3 sine x. And that would be your final answer. So you're just expanding it using your composition property, and then evaluate wherever you have an actual trig. All right, let's get down to what we really want to be able to do with this, and that is solve an equation. Because when you look at this, nothing is squared, so I can't use Pythagorean identity to put it all in terms of one trig. The only possibility we have is our linear combination. So we're just working on this side for a second. So we know that A is going to be the square root of 2 squared plus 5 squared. So that is going to give us the square root of 29. Those are both positive, so we'll be in the first quadrant. There won't be any problems there. So the opposite over the adjacent. And again, maybe I should have graphed this, but it will all be in the first quadrant. So this is 2, this is 5. That'll end up being square root of 29. Here's my x, or my theta. So inverse tan of 5 over 2, rounding to the nearest degree. You don't have to give decimals for the degrees. That gives me 68. All right, so what does that do for us? Well, that says I can now set up an equation that is going to read square root of 29 cosine x minus 68 degrees, we really should say theta there, that's bugging me, equals 4. All right, and that's what we want to solve. So we solve it the way we've been solving things. I'm going to first divide both sides by rad 29. So that is gone. And then we take the arc cosine of both sides. So I have here, on this side, it'll still be theta minus 68, which is going to equal the arc cosine of 4 over rad 29. So theta minus 68 is going to equal, so you go to your handy dandy calculadora, and we get that the inverse arc cosine 4 over rad 29 is going to give me 42 degrees. So this is going to be 42 degrees plus or minus plus every 360n, every time we go around the circle. All right, so our final goal is to solve for theta. So that's going to be 68 plus 42 and 68 minus 42 plus our 360n. So our final solution, please do not ever leave me anything to have to work out for you, is going to be 68 plus 42 gives me 110 plus 360n. 68 minus 42 is 26 degrees plus 360n. And all it asked for here was solve. It didn't say within a particular interval, so I'm assuming they just want their general solution. And that would be it.